Dear students, we are explained about matrices in the previous class. What is matrices, what are the types of matrices, and what is minors, cofactors and adjoint of a matrix, even what is inverse of a matrix, and also we have solved some second 2 cross 2 matrix problems also, and also we are verified what is A into adjoint A and adjoint A into A is equal to determinant A into I. Now, let us solve a few problems on adjoint and inverse of a matrix. Next, find adjoint of a matrix. Find adjoint of a matrix. Find adjoint of A is equal to Let us solve one 3 cross 3 matrix. 1 1 3 minus 2 1 3 minus 2 minus 2 minus 4 minus 3 and 1 minus 2 1 minus 2 1 minus 2 1. Okay, this is a 3 cross 3 matrix. Now, we have to find adjoint of this particular matrix. Adjoint of a matrix means, first of all we have to find the cofactor for each and every element in the matrix, cofactors. Then we have to write a cofactor matrix, then you transpose the cofactor matrix, we get a adjoint of a matrix. Let us go for finding a cofactor of 1 is equal to, I think you are familiar to find a cofactors. So, we have to multiply each and every element with a proper signs, that is minus, plus, minus, minus, plus, minus, minus. We have to multiply each and every element with the plus, minus, plus, minus, plus, minus and minus, plus, a minus. Cofactor of 1 is equal to plus 1 into. Actually, we have to change this matrix into a determinant. So, determinant A is equal to 1 3 minus 2 minus 2 minus 4 3 and 1 minus 2 1 1, and we have to multiply proper signs. First plus 1 into. So, you neglecting this corresponding row and corresponding column of element, we get a second order determinant, it is minus 4 3 minus 2 1, that is equal to 1 into minus 4 into 1 is minus 4 minus of minus 2 into 3 is minus 6 that is equal to 1 into minus is plus 6 minus 4 is 2, that is equal to 2. 1 into 2 is equal to 2. Now, minor of the element 1 is equal to 2. Similarly, cofactor of 3 is equal to minus 3 into. See, we get minus 2, this is second column, a first row, we have to delete minus 2 3 1 1, that is equal to minus 3 into minus 2 into 1 is minus 2, 3 into 1 is minus 3, that is equal to minus 5 into minus 3 is 15. Minus 2 minus 3 minus 5 into minus 3 is 15. Next, cofactor of minus 2 is equal to plus into minus 2. You neglect this first row and third column, we get minus 2 minus 4 1 minus 2, that is equal to minus 2 into minus 2 minus of 1 into minus 4 minus 4. So, it becomes minus becomes plus. So, 4 plus 2 6 2 is minus 12 is the cofactor of the element minus 2. Next, cofactor of minus 2. Cofactor of minus 2 again is equal to minus into minus cofactor of, just a minute, cofactor of 1 is equal to cofactor of 1 is equal to this is just we have to multiply by a sign, not with a number, this is plus minus 4 minus 2, so 1 is same 2, it becomes 2, this is minus into minus 6 into minus 6 is a plus 6, this is 6, this is plus into minus 2 plus 4, that is equal to 6 into minus 1 is again minus 6 4 plus 2 is 6. Next, cofactor of minus 2 is equal to minus into. See, this belongs to second row and first column. The rest of the elements are 3, minus 2, 1, that is equal to minus of 3 plus 3 minus 4. So, minus 2 into minus 2 is plus 4, that is equal to 3 minus 1 is minus 1, minus 1 into minus is plus 1. Next, cofactor of minus 4, is equal to plus into. So, this is second row, second column. So, 1 minus 2, 1 minus 2, 1, 1, that is equal to 1 minus of minus 2 is equal to 3. Cofactor of 3 is equal to minus into. This is a third column and a second row. See, this belongs to third column, second row. 1, 3, 1, 3, 1, minus 2, that is equal to minus of minus 2, minus 3, minus 5 into minus, that is equal to a plus 5. Next, cofactor of 1 is equal to plus into. So, third row, first column. So, 3, minus 2, minus 4, 3, minus 2, minus 4, 3, that is equal to 3 3s are 9, minus 4 2s are 8, 9 minus 8 is equal to 1. Next, cofactor of minus 2. Is equal to minus second row, second column, third row, 1 minus 2, 1 minus 2, 1 minus 2, cofactor of minus 2, 1 minus 2. So, this row minus 2 means this row and this column, minus 2, 3, that is equal to minus of 3 minus 4, that is equal to 3 minus 4 is minus 1, minus of minus 1 is a plus 1. Last one, cofactor of 1 is equal to plus into. See, third row, third column, 1 3, minus 2, minus 4, that is equal to minus 4, minus of minus 6, that is equal to plus 6, that is equal to 6 minus 2 is equal to 2. So, now we get a cofactor of each and every element in the matrix. Let us write a cofactor matrix. Cofactor matrix, that is equal to cofactor of 1. Cofactor of 1 is 2, cofactor of 3 is 6, cofactor of minus 2 is minus 6. Similarly, 1 3 5, 1 1 2. This is a cofactor of matrix. Then what is adjoint of a matrix? Transpose of cofactor matrix. Therefore, adjoint A is equal to just to transpose 2 6 minus 6 1 3 5 1 1 2. This is adjoint of a matrix. How to find adjoint of a matrix? We have to first of all find the cofactor for each and every element in the matrix. Then you write a cofactor matrix. Then transpose the cofactor matrix. We get the adjoint of a matrix. But one is initially we have to change the matrix into determinant, and we have to multiply the determinant by a proper signs like plus, minus, plus, minus, plus, minus, plus, minus, plus. This is okay. Next, similarly we can find inverse of a matrix also. Inverse of a matrix. Inverse of a matrix. Let us find A inverse means inverse of a matrix. For a matrix A is equal to 1 0 2 1 0 2 1 0 2 0 2 3 0 2 3 0 2 3 and 1 3 4 1 3 4. this is the matrix A, then we have to find out inverse of the matrix, inverse of the matrix. See, inverse of the matrix is adjoint A by determinant A, adjoint of a matrix divided by determinant of a matrix, adjoint of a matrix divided by determinant of a matrix. But determinant of a matrix should be equal to, should not be equal to 0, because if A delta A becomes 0, then A inverse not exist, A inverse not exist. That is why first we have to find is what is delta A, what is determinant of a matrix. Okay. If determinant of a matrix becomes 0, then A inverse not exist. That is why first of all we have to find what is the value of the determinant, determinant of a matrix, determinant of a matrix. Let us find plus minus plus to find a determinant value, that is 1 into plus 1 into 2 into 4 is, or 1 into 2 3 3 4 minus 0 into 1 2 1 4 1 2 1 4 0 into 0 0 0, this is a second column first row, okay, minus 0 into second column a second row, 0 into 1 2 1 4 plus 2 into 0 2 1 3 0 2 1, that is equal to 1 into 4 into 2 is 8 minus 3 into minus 3 is minus 9 minus 0 plus 2 into 0 minus 2, that is equal to 8 minus of minus is plus 8 plus 9 is 17 minus 2 into plus 2 is minus 4, 17 minus 4 is equal to 13. So, 13 is the value of the determinant that is not equal to 0, therefore, A inverse exists, A inverse exists. Suppose if the value of the determinant is equal to 0, the A inverse does not exist, If the determinant value becomes 0, no need to go for a finding cofactors or a adjoint of a matrix, because A inverse does not exist. If delta A is equal to, delta A is not equal to 0, definitely A inverse exists. Now, let us find adjoint of a matrix, let us find adjoint of a matrix. So, to find an adjoint, what we have to do? We have to write a cofactors, cofactor of 1 is equal to plus minus plus minus plus minus plus minus plus. Cofactor of 1 is equal to plus into 2 3 3 4, that is equal to 8 minus 9, that is equal to minus 1. Cofactor of 0 is equal to minus into this is minus 3, just a minute, 2 4 into 4 is delta value becomes, this is for to find a delta A, why I written minus 3 here, this is not minus 3, 1 2 3 3 4, actually it is a plus 3, okay, 4 2s are 8, minus 9, 4 2s are 8, minus 9, this is plus 3, okay, 4 2s are 8, minus 9, minus 0 into 0, 0 into any value is 0, plus 2 into 0 minus 2, that is equal to 8 minus 1 is 9 is minus 1, minus 1, 2 into minus 2 is, that is equal to minus 5. Actually, I have not written 3 properly. Okay, fine. Next, a cofactor of 0 is equal to, this belongs to a second column, a first row 0 3 1 4, that is equal to minus of 0 minus 3, that is equal to 3, Next, cofactor of 2 is equal to plus into, this is first row, third column 0 2 1 3, that is equal to 0 minus 2, that is equal to minus 2. Cofactor of 0 is equal to minus, this is minus 0, 2, 3, 4, 0, 2, 3, 4, that is equal to minus of 0 minus 6, that is equal to plus 6. Cofactor of 2 is equal to plus into, see we have to multiply plus minus orderly, plus cofactor of 2 is, this is second row second column, 1, 2, 1, 4, that is equal to 4 minus 2 is equal to 2. Cofactor of 3 is equal to minus of, 3 means a second row third column, 1, 0, 1, 3, that is equal to minus of 3 minus 0, that is equal to minus 3, Next, cofactor of 1 is equal to 1, third row first column, plus into third row first column means 0, 2, 3, 4, 0, 2, 3, 4, that is equal to 0 minus 6 is equal to minus 6. Cofactor of 3 is equal to minus of, 3 is equal to, so third column second row 1, 0, 1, 3, 1, 0, 1, 3, that is equal to minus of 3 minus 0, that is equal to minus 3. Last element, cofactor of 4 is equal to plus into, cofactor of 4 plus into, so third row third column, so 1, 0, 0, 2, 1, 0, 0, 2, that is equal to 2 minus 0 is equal to 2. Now, we got the cofactor element for each and every element. Let us write cofactor matrix. Cofactor matrix is equal to, cofactor matrix A is equal to, okay, A is equal to, cofactor matrix A is equal to minus 1, 3, minus 2, 6, 2, minus 3, minus 6, minus 3, 2, 2, 2. Next, adjoint of a matrix. Adjoint A is equal to transpose of a cofactor matrix, minus 1, 3, minus 2, 6, 2, minus 3, minus 6, minus 3, 2, 2. So, this is adjoint of a matrix, that is adjoint of a matrix. Next, A inverse of a matrix is equal to adjoint of a matrix divided by determinant of a matrix. Adjoint of a matrix divided by determinant of a matrix, that is 1 over what is value of determinant A, 1 over minus 5 into minus 1, 6, minus 6, 3, 2, minus 3, minus 2, minus 3, 2, minus 3, minus 2, minus 3, 2. See, adjoint A by determinant A is nothing but 1 over determinant A into adjoint A, both are same, that is why I written 1 over minus 5 into adjoint of a matrix, or we can multiply this minus 5 or 1 over minus 5 for each and every element in the matrix, okay, both are same, but this is the, I think this is sufficient. A inverse is equal to adjoint A by determinant E. This is a way of finding inverse of a matrix in 3 cross 3 matrix, So, first we have to find delta determinant of the A and it should be not equal to 0. Then we have to find cofactors for each and every element. You write cofactor matrix, adjoint of a matrix, you write a formula for A inverse or A inverse of a matrix, you substitute, that ends the problem. This is the way of finding inverse of a matrix, But here we should have a patience to write a cofactor element for each and every element in the matrix, that is very important, okay. See, matrix or a determinant is very easy, but you should have a patience, a little patience to write. Okay, next, characteristic equation and its roots. Actually, in a 2 cross 2 matrix, we are verified what is adjoint of a matrix into A into adjoint A is equal to adjoint A into A is equal to determinant A into I. It is also possible in a 3 cross 3 matrix, but it is very lengthy one. Next, characteristic equation and its roots. Characteristic equation and its roots, characteristic equation and its roots, characteristic equation and its roots of a square matrix. It is applicable only for a square matrix, See, if A is any square matrix, if A is any square matrix, it is a condition. Square matrix means what? Number of rows should be equal to number of columns. If you say a matrix is a square matrix, so if it is a 2 number of columns, definitely 2 number of rows, or a 3 number of rows, 3 number of columns. It is a must, it is a must. Now, determinant of A minus lambda into I is equal to 0 is called a characteristic equation of a square matrix. Determinant of A minus lambda into I, A minus lambda into I is equal to 0, where A is a given matrix, lambda is called a constant, lambda is called a constant of a matrix, or it is also called as eigenvalue, it is also called as eigenvalue, where I is called what? It is I means identity matrix or a unit matrix, So, determinant of A minus lambda is equal to 0 is called a square matrix, is called characteristic equation. Now, suppose by substituting A value, lambda and I identity matrix, we get one equation, you solve that equation, or if you replace lambda by, after getting actually we equation get in terms of lambda, substituting A value, lambda and I identity matrix, we are getting an equation in terms of a lambda, you simplify that equation or you factorize that equation, we get a values of lambda, this like for example, we are getting values equal to 1 and 2 or 1 and minus 2, where these values are called eigenvalues, and they are also called as characteristic roots. Eigenvalues are characteristic roots. Let us solve one problem, then we can understand better, Okay. So, determinant of A minus lambda I is equal to 0 is called characteristic equation. If you simplify that equation, we get a values of lambda, that values are called characteristic roots, and also they are called eigenvalues, Next, find a characteristic equation and roots of a matrix, A is equal to, 3 minus 2, 2 minus 1, 3 minus 2, 2 minus 1, 3 minus 2, 2 minus 1. Now, what is characteristic equation? Determinant of A minus lambda is equal to 0, determinant of A minus lambda into I is equal to 0. Now, determinant of what is A? 3 minus 2, 2 minus 1, minus lambda into I. See, minus lambda into what is I? Identity matrix of order as that of A, it is a condition. So, A is a, you see, it is a determinant, no? Determinant of the order of the determinant should be equal to order of the identity 1, or a order of identity matrix should be equal to order of A. Now, lambda into, if it is a second order or a 2 cross 2, you write 1 0 0 1, 1 0 1 is equal to 0, it becomes, see, 3 minus lambda into 1, 3 minus lambda, next minus 2 minus 0, minus 2 minus 0 is minus 2, 2 minus lambda into 0 is 2, minus 1 minus lambda into 1 is minus 1, minus lambda is equal to 0. It is a determinant, no? You simplify or you find the value, 3 minus lambda into minus 1 minus lambda, minus of 2 into minus 2 is minus 4, that is equal to 0. You simplify. See, minus 1 into 3 is minus 3, minus 1 into minus lambda is a plus lambda. Next, minus lambda into plus 3 is a minus 3 lambda. See, minus lambda into 3 is minus 3 lambda, minus lambda into minus lambda is plus lambda square, minus of minus is plus 4 is equal to 0, that is equal to 0. Now simply minus 3 plus 4. So, 4 minus 3 is 1, lambda minus, first you write lambda square, lambda minus 3 lambda is minus 2 lambda, 4 minus 3 is plus 1 is equal to 0. Now, this equation is called characteristic equation. This equation is called characteristic equation. Now, you can solve this equation or we can factorize this equation. Finally, we can getting the values of lambda. You see, it is like what? Lambda square minus 2 into lambda plus 1 square. It is like an expansion of a minus b whole square. A minus b whole square, or a lambda squared minus lambda plus 1 is equal to 0. You take lambda common. So, lambda minus 1 minus 1 common, lambda minus 1 is equal to 0. Therefore, lambda minus 1 into lambda minus 1 is equal to 0. Therefore, lambda is equal to 1 and 1. Lambda is equal to 1 and 1. These values, these lambda is equal to 1 or lambda is equal to 1 is there, no? They are called characteristic roots. Characteristic roots, or they are also called as eigenvalues. Eigenvalues. So, lambda is equal to 1 and 1. Lambda is equal to 1 and 1 are called the characteristic roots or eigenvalues. Now, what is the question? Find the characteristic roots or find the characteristic equation and roots of a matrix. What is characteristic equation? Determinant of a minus lambda I is equal to 0. Determinant of a minus lambda I is equal to 0. You substitute a value, given a problem, minus lambda into identity matrix. Identity matrix of order is equal to a matrix of A, or the order of A is 1 0 0 1. If it is a 3 cross 3 matrix, we have to write 1 0 0 0 1 0 0 0 1 like that. Next, you are already familiar how to subtract the matrices. So, you 3 minus lambda into 1 is 3 minus lambda, minus 2 minus 0 is minus 2, 2 minus lambda into 0 is 2, minus 1 minus lambda into 1 is minus 1 minus lambda. Finally, okay, you can find the values of determinant by cross multiplying these two minus these two. So, we are achieving the lambda square minus 2 lambda plus 1 is equal to 0. This equation is called what? Characteristic equation. And you solve this equation, we get the values of lambda are called characteristic roots. Roots or they are also called as eigenvalues. Let us solve one more problem. Actually, in our syllabus, this is restricted to only a 2 cross 2 matrix. Syllabus itself. Let us find one more problem. A is equal to 2301. 2301. Find characteristic equation and its roots. First of all, what is characteristic equation? A minus lambda I is equal to 0. The A 2301 minus lambda into 1001 is equal to 0. So, determinant of 2 minus lambda, 3 minus lambda into 0 is 3, 0 minus lambda into 0 is 0, 1 minus lambda into 1 is 1 minus lambda, that is equal to 0. Next 2 minus lambda into 1 minus lambda, 2 minus lambda into 1 minus lambda minus 0 is equal to 0. Now, in this case 2 minus lambda 2 minus lambda into 1 minus lambda is equal to 0. Here no need of multiplying these two, we can directly write lambda is equal to 2 and lambda is equal to 1. So, now lambda is equal to 1 and lambda is equal to 2 are called eigen values of the given a square matrix. So, suppose if you want an equation, if you want a characteristic equation, so we can find or we can multiply these two that is so 1 into 2 is 2 minus 1 into lambda minus lambda, next minus lambda into 2 is minus 2 lambda, minus lambda into minus lambda is plus lambda square. So, that equation becomes lambda square minus 3 lambda plus 2 is equal to 0. This is the characteristic equation, it is a characteristic equation, or we can directly say 2 minus lambda into 1 minus lambda is a characteristic equation. Next, let us go for one more problem. A is equal to a square matrix A is equal to 8 minus 1 6 8 minus 1 6 1 8 minus 1 6 1 1. Now, determinant of A minus lambda I is equal to 0. We have to write this a very important one, determinant of A minus lambda is equal to 0. Next, determinant of A 8 minus 1 6 1 minus lambda into 1 0 0 1 is equal to 0 Now, so it becomes 8 minus lambda minus 1 6 1 minus lambda, determinant of 8 minus lambda minus 1 6 1 minus lambda is equal to 0. You find the value, it becomes 8 minus lambda into 1 minus lambda minus of minus 1 into 6 is minus 6 is equal to 0. Next, 1 into 8 is 8, minus 1 into 1 is minus lambda, minus lambda into 1 is minus lambda into 8 is minus 8 lambda, minus into minus plus lambda square, minus of minus plus 6 is equal to 0, Simplify, lambda square minus lambda minus 8 lambda minus 9 lambda, 8 plus 6 is 14 is equal to 0. This is the characteristic equation in terms of lambda, Now, to find an eigenvalue or a characteristic roots, we have to simplify this equation by a factorization. Here number is 14, what are the roots? So, what are the roots? So, 7 twos are the 2 minus 7 minus 2, minus 7 into minus 2 is plus 14, minus 7 lambda minus 2 lambda is minus 9 lambda, Therefore, equation becomes lambda square minus 7 lambda or lambda squared minus 2 lambda first, next minus 7 lambda plus 14 is equal to 0, You take lambda common, so it becomes lambda minus 2 minus 7 common, lambda minus 2 is equal to 0, Next, lambda minus 2 common, so it becomes lambda minus 7 is equal to 0. So, lambda is equal to 2 and lambda is equal to 7 are the characteristic roots or eigenvalues of the given matrix. So, A is equal to 8 minus 1 6 1, we have to take determinant of A minus lambda I is equal to 0, write A value minus lambda into I value is equal to 0. So, that it becomes 8 minus lambda minus 1 6 1 minus lambda is equal to 0, 8 minus, therefore, 8 minus lambda into 1 minus lambda minus 6 into minus 1 is minus 6 is equal to 0. So, you multiply these two, 1 into 8 is 8, 1 into minus 1 is minus lambda, 1 into minus lambda is minus lambda, minus lambda into plus 8, minus lambda into plus 8 is minus 8 lambda, minus lambda into minus lambda is plus lambda squared, plus minus of minus plus 6 is equal to 0, it becomes lambda squared minus 9 lambda plus 14 is equal to 0. This is called the characteristic equation, characteristic equation. Next, you simplify this equation by factorization. So, lambda squared minus 2 lambda minus 7 lambda plus 14 is equal to 0. See, because here we have a 14, we have 2 roots minus 2 minus lambda, minus 2 not roots, actually we can split the 14 into minus 7 minus 2. It is a earlier method, it is a school method. Okay, so that it becomes lambda squared minus 2 lambda minus 7 lambda plus 14 is equal to 0. You take lambda common, so lambda remains, lambda minus 2 remains, so lambda into lambda minus 2, again you take minus 7 common, so lambda minus 2 is equal to 0. Therefore, again out of these two, lambda minus 2 is the common, therefore lambda minus 2 into lambda minus 7 is equal to 0. Finally, lambda is equal to 2. It means actually this means lambda minus 2 is equal to 0 and lambda minus 7 is equal to 0. Lambda minus 7 is equal to 0. So, it ends with lambda is equal to 2 and lambda is equal to 7. So, these are the characteristic roots are eigenvalues. Characteristic roots are eigenvalues of the matrix. Next, last part of the matrix is a Cayley-Hamilton theorem. Cayley-Hamilton theorem. It is a theorem. So, every theorem have its own statements. If there is a theorem, there is a statement. The statement of the theorem is every square matrix satisfies its characteristic equation. Every square matrix satisfies its characteristic equation. Every square matrix statement. Every square matrix satisfies its characteristic equation. Characteristic equation. Every square matrix satisfies its characteristic equation. Let us solve one problem, then you can understand better. So, this is the statement of Cayley-Hamilton theorem. You are already familiar what is a characteristic equation. Let us go for a problem. Verify Cayley-Hamilton theorem for a matrix. Cayley-Hamilton theorem for a matrix A is equal to 3 minus 1 2 6. 3 minus 1 2 6. See here, we have to find characteristic equation. How to find a characteristic equation? We have to go for a determinant of A minus lambda is equal to 0. So, determinant of A minus lambda into I is equal to 0. Next, A 3 minus 1 2 6 minus lambda into I 0 1 0 0 1 is equal to 0. So, that it becomes 3 minus lambda minus 1 2 6 minus lambda is equal to 0. Next, you multiply these two. Okay, you simplify the determinant. So, that it becomes 3 minus lambda into 6 minus lambda minus of minus 2 is equal to 0. So, finally, you multiply 6 3s are 12 minus 6 lambda minus lambda into 3 is minus 3 lambda plus minus lambda into minus lambda is minus lambda plus lambda square plus 2 is equal to 0. Therefore, lambda square minus 9 lambda minus 3 lambda minus 6 lambda is minus 9 lambda. Next 12 plus 2 is equal to 14. Similar type, lambda squared minus 9 lambda plus 14 is equal to 0. 14 is equal to 0. Now, this is a characteristic equation. What is the theorem statement is, every square matrix satisfies its characteristic equation. Every square matrix satisfies its characteristic equation. Now, see, this is a characteristic equation in terms of lambda. To verify a Cayley-Hamilton theorem, we have to replace lambda by a. We have to replace lambda by a. In place of lambda, you write a. So, therefore, it becomes a square minus 9 lambda plus, in terms of in the place of a constant, you write 14 into I. 14 into I is equal to 0, where I is a identity matrix. Why in place of 14 we are writing 14 into I is, any value multiplied by identity matrix is remains the same. So, 14 into I is equal to 14 into I is equal a squared minus 9 lambda plus 14 into I is equal to 0. Now, see, we have a matrix A, you find out a square, you find out 9 lambda plus 14 into I, you substitute all the value in the given equation, it should be equal to 0. Let us find a squared first. A squared is equal to 3 minus 1 2 6 into 3 minus 1 2 6. A into A is a square. That is equal to 3 into 3 9 plus minus 1 into 2 is minus 2 minus 3 into 3 plus minus 1 into 2 is minus. Next 3 into minus 1 is minus 3 into minus 1 is minus 3. Next minus 1 into a plus 6 is minus 6. Next 2 into 3 is 6 plus 2 into 6 into 2 is 12. Next 2 into minus 1 is minus 2, 6 into 6 is plus 36. That is equal to 9 minus 2 is 7, minus 3 minus 6 is minus 9, 6 plus 12 is 18, 36 minus 2 is 34. Now, we got the value of a squared as 7 minus 9 18 34. 7 minus 1 18 34. Next 9 lambda. 9 lambda is equal to 9 into lambda, sorry 9a, sorry, it is 9a is 9 into, that is equal to 9 into 9a. So, 3 minus 1 2 6, that is equal to 9 3s are 27, 9 into minus 1 is minus 9, 9 into 2 is 18, 9 into 6 is 72, sorry 54. This is 9 into a. Next is a 14 into I. 14 into I is equal to 14 into I is 1001, that is equal to 14 0 0 14 0 14. Next you write an equation, a square minus 9a plus 14 into I is equal to 14 into I is equal to a is equal to 0. A squared value write 7 minus 9 18 34 minus 9a is 27, 9a is 27 minus 9 18 54 plus 14 0 0 14. Next 7 minus 27 is minus 20, it is not 7, it may be 3 3s are 9 plus 2, first row first column, actually something is wrong in multiplication, 3 into 3 plus minus 1 into 2 is minus 2, 3 minus 1 2 6. Okay, let us see. 7 minus 27 is minus 20. Maybe something wrong in the characteristic equation. 12 plus 2 is 14. Okay. 7 minus 27 is minus 20, minus 9 minus of minus plus 1 0, 18 minus 18 0, 34 minus 54 is 20, 20 minus 14, something is wrong here, something is wrong in the problem, something is wrong in the problem. Let us solve one more problem. Let us solve one more problem. The board place is insufficient, the major problem. Verify a Cayley-Hamilton theorem for the matrix 2301 2301 or 3412. A is equal to 3412. Next, determinant of A minus lambda into I is equal to 0. So, determinant of A 3412 minus lambda into 1001 is equal to 0. It becomes 3 minus lambda 4 1 2 minus lambda is equal to 0. Therefore, 3 minus lambda into 2 minus lambda minus 4 is equal to 0. So, 6 minus 2 lambda minus 3 lambda plus lambda squared minus 4 is equal to 0. Lambda square minus 5 lambda, 6 minus 4 is plus 2 is equal to 0. You replace lambda by A, therefore, A squared minus 5A plus 2 into I is equal to 0. 2 in A squared minus 5A, A squared minus 5A plus 2 into I is equal to 0. Now, let us find A squared. A squared is equal to 3 4 1 2 3 4 1 2 3 4 1 2 is equal to first row first column 3 into 3 9 plus 4 into 1 4, 3 into 4 12 plus 4 into 1 is 8. Next, second row first column 1 into 3 3 plus 2 into 1 is 2, 1 into 4 is 4 plus 2 into 2 is 4. So, that is equal to 13 20 5 8 is A squared is equal to 13 20 5 8. Next, 5 lambda, next is 5 lambda, 5 into lambda, that is 5 is into 3 4 1 2 3 4 1 2 3 4 1 2, that is equal to 15 20 5 10. This is 5 lambda. Next 4 into 2 into I, 2 into I is equal to 2 into 1 0 0 1, that is equal to 2 0 0 2 2. Next, A square minus 5 into A plus 2 into I is equal to 0. You substitute the A squared value 13 20 5 8 minus 5 into A 15 20 20 5 10 plus 2 0 0 2 is equal to 0. Now, 13 minus 5 is minus 2, 20 minus 20 is 0, 5 minus 5 0, 8 minus 10 is minus 2 plus 2 0 0 2 is equal to 0. Now, minus 2 plus 2, that is equal to 0 0 0 0 is equal to 0. See, actually in previous problem something is wrong, something is going wrong. Now see, every square matrix satisfies its characteristic equation, means you find a characteristic equation, you replace lambda by A, and you finally you find A squared and any value multiply by a matrix, and again you substitute the all values in the given equation, finally it must ends with 0 0 0 0. Then only we can say every square matrix is satisfies its characteristic equation. Okay. Today we are solved what is adjoint of a matrix, what is inverse of a matrix, characteristic equation and its roots, and Cayley-Hamilton theorem. Okay, thank you. I will continue in the next class. Actually, of course, while solving a problem, some mistake is going on. Okay, I will rectify in the next problem. Thank you very much.